So here's where, if we were in the classroom, I'd get to send you off on this fun lab. And the basic lab question is this. Let's say that you go and you buy this pair of sunglasses on the street. How can you tell if these are polarizing or not? And what does that even mean? Right. Polarizing sunglasses will block out 50% of the light, but they'll also have this selective filter that either takes all of the vertically polarized light and lets it pass, or lets all the horizontally polarized light pass. Not all filters do this. Some are brightly colored, some are just dyed black. All right, so how can you figure it out? Now, humans don't have the ability to see polarized light. So, what we would need to do is use one of three methods. Actually, way number one, in order to figure out if a pair of glasses is polarized or not, is to just compare it to another pair of glasses that you already know is polarized. If you take the two lenses and rotate them with respect to each other, well, you should get this lightening and darkening effect that's seen in this GIF. However, if you rotate it and there is no change in brightness whatsoever, you know at least one pair of those glasses is not polarizing. Now, it turns out that this is harder to do than I imagined. When you do this in class, you can just hold it in place, but when you try to do this holding two pairs of sunglasses plus a camera, it doesn't work out so well, which you'll see later. But this is method number one. Method number two is instead of comparing to a known pair of polarized glasses, what if we just took a source that we knew was polarized? Remember, we know that screens like computer screens, iPad screens, TV screens put out polarized light. And fun fact, since they use that polarized light as part of the color making process of a monitor, if I rotate it, sometimes I can get the light to completely disappear. At the correct angle, which looks like it's about a 45, all of the color on the screen disappears even though we know the screen is still putting out light. Now, that's with the MacBook, but different types of screens, like the iPhone or iPad, work a little differently. So what you'll notice in this one is with an iPad, the color never completely goes away, but it does change. That slight color change from the polarized filter shows that this must be a polarized pair of sunglasses. Same with the iPad. It does a slightly different way of producing color using polarized light, and so you get slight color changes, slight brightening and darkening, but it doesn't go all the way black like it did with the MacBook. So those are the first two ways. But what if you don't have a screen nearby? And what if you don't have a different pair of sunglasses you already know to be polarized? The third way is pretty straightforward. So we know that the glare off non-metal objects creates polarized light. In this case, this is horizontally polarized light because the puddle itself is horizontal, which blocks the vertical parts of the wave. So notice in this, I can check to see if this is a polarizing filter because in some orientations it lets half the light through, and in other orientations it lets a lot less. I would see a gradual brightening and darkening just like I would if I were comparing two filters against each other. See how it's brightest when the filter is vertical and dimmest when it's horizontal? Neato! Now, since the car is putting out mostly horizontal polarized light, and my sunglasses are vertically polarized, this means it blocks the majority of glare. That's why most sunglasses are vertically polarized, because most of the glare we deal with is off horizontal surfaces. So to sum up, how to figure out if sunglasses are polarized or not could be done one of three ways. It could be done by taking a pair of sunglasses you know are polarizing and ones that you don't, and testing them against each other, maybe a little bit more cool. You know what I'm trying to do here, right? You could take it, hold it up to a computer screen, something that you know is sending out polarized light, and rotate it. Or you could look at a glare off a puddle or other horizontal, non-metal surface and rotate it to see if it minimizes the glare. So those are the three ways to tell if a set of lenses are polarizing or not.